All right, we're in it now, boys and girls. This is assignment 3B. This is truly where we are going to get started with derivatives. We mentioned yesterday, or mentioned in the last video, that a definition of a limit is this limit as h goes to 0 of f of x plus h minus f of x all over h. And then we also had the ability to take a derivative at a point. Okay, what we're going to do today is I was leafing through the pages of the lesson leading up to this. And if you're wondering what I'm referencing, I'm looking at the book pages 134 through 142, and here is kind of like the highlighted version of what you need to know to accomplish the assignment today. All right, the one is when I'm going to be taking a derivative. Okay, this is a symbol for a derivative, derivative with respect to x. So what is the derivative of a constant, like a number? And that answer is 0. An example is this. If f of x is equal to 3, f prime of x, the derivative, is equal to 0. If it's just a straight up number, it's equal to 0. The next is called the power rule. So let's say I have an x to some variable n. Okay, so x is the important number, and x is to some power. All right, the power drops down and gets reduced by 1. Okay, it's kind of hard to explain and hard to see when it's x's and n's and things like that. So again, let's say I have f of x equal to x to the 4th power. The derivative of this is going to be 4x to the 3rd. So the power drops down and you reduce it by 1. Okay. What else is in these notes? You can add them. You can. You can't multiply. You can't multiply. That's a different thing for a different time. So we got the derivative. Again, I'm just leafing through the pages here real quick. So here we go. The constant rule, the power rule, the constant multiple rule. So again, you can put these first two things together. So let's say I have f of x is equal to 3x to the 5th. A 3x to the 5th. All right, so this derivative is, this 5 drops down, so this 5 comes down, so that's a 3, a 5, and x to the 4th, so this is going to be 15x to the 4th. So when that comes down, it comes down as a multiple of whatever's up front. As I said, you can add and subtract. You cannot multiply and divide. Again, those will be coming later. Derivatives of a sine is cosine. Derivative of cosine is negative sine. So if you ever take a derivative of something that is a the answer is almost always negative. So right now we just know cosine. So sine is a cosine. Cosine is a sine, however, it's a negative sign. And I think the last bit of info is the derivative of an e. Derivative of an e is an e. So the d dx of e to the x is e to the x. All right. So again, here's the big lessons today. If f of x is equal to just a straight up number, okay, the derivative is equal to 0. If you have an x to a power, let's go 4x to the negative 5 or something like that. I guess that's an advanced version. Let's make it simple first, sorry, and then I'll make it complicated. So that comes down, so 6 times 4 is 24, and then the exponent gets reduced by 1. All right, so on to the advanced version. What if it were 4x to the negative 6? All right, well, it still drops down and multiplies, so negative 6 times 4 is negative 24, and the exponent reduces by 1, so minus 1 would yield a negative 7. All right, what else did we learn today? Sines and cosines. So if f of x is equal to sine x, the derivative is equal to cosine x. Similarly, if f of x is equal to cosine x, the derivative is negative sine of x. And last but not least is the e to the x. So if f of x is equal to e to the x, the derivative of that is equal to e to the x. And so that would get you going. The big one that you're going to use 95% of the time is that one right up there. You got to feel comfortable with basic derivatives of just functions. So the power rule. So the top drops down, so it multiplies down and then reduces by 1. Okay. So our problems begin here is find the slope of a graph of a function at the given point. Use the derivative feature of a graphing utility to confirm your results. Okay, I'll get to that second part. But, okay, so the slope of a graph at any point is the derivative. It's the instantaneous change, it is the tangent. So the slope of any tangent. Let's first rearrange this problem to make it a little bit more understandable. So I have the number 8, okay, as a numerator, and then I have a bottom x squared. So that's the same thing as saying x to the negative 2. So that's 8x to the negative 2. The reason I do that is because it's a little bit easier to take the derivative of it when it's written as such. So it multiplies down, so that's negative 16, and then the negative 2 reduces by 1. So that'll be negative 3. All right, so that is the derivative. That is the slope of my graph at any point. All right, so they want to know what is the slope of the original when it was 2, 2. All right, so that means the slope when the x value is 2. The slope when the x value is 2. So that's negative 16 x to the third power on bottom. So that's negative 16 over 8, which is negative 2. The slope at that should be negative 2. Now, to use the graphing utility to confirm your answer. Okay, so let's go ahead and fire up our calculator here. They want me to do it graphing. Okay, so I will do it the graphing way. There's another way, but I'll do it the graphing way. So what I want to do is I want to graph this original equation. So 8 divided by x squared. I'll go zoom 6. And then that is the picture of 8 over x squared. They want to know what is the slope when x is equal to 2, aka what is the derivative when x is equal to 2. So again, when you need to calculate do some math with a picture, a lot of times it's under this calc tab where that's where I'm going to go. So I'm going to go shift calc, and what I want to do is I want to find the derivative, okay? The derivative, which is this dy dx. That's the derivative, option 6. So what I need to do now is I am just going to enter the x value in which I want this thing to find the derivative at. Okay, so I hit 2, and there you go. All right, so that is the derivative at that point, and it says dy dx is equal to -2. It's not 100% accurate, but that's really close. All right, let's go ahead to number 33. All right, so y is the same thing as saying f of x. It's the same difference. So y prime, which is the same thing as saying f prime of x. Actually, I'm going to say f prime of x. It's a little bit easier. So the derivative of that, the 4 multiplies down, reduces by 1, and the -3 goes to a 0. You can add and subtract, and so that 3 goes away. It's the derivative of a constant. Okay, we are going to find the slope when x is equal to 1. And again, where I'm getting this is from the point that they provide me. And so the slope should be 8. I'm going to use my graphing utility to confirm. So I clear that out and enter 8x to the 3rd. And I'm going to calculate, shift calculate, the derivative, number 6, when x is equal to 1. Oh, I'm like, what the hell? I didn't enter the original f of x. I entered the derivative. I'm sorry, 2x to the 4th minus 3. I'm slow. Sorry. All right, so that is my graph. Doi. I'm like, what the heck? All right, there's my graph. I'm sorry. And now I need to calculate the derivative when x is equal to 1. There it is, 8. I know I didn't do anything wrong. Okay, there it is. All right, so think of this kind of like as being f of x of sine x minus x, something like that. All right, so the derivative, sine goes to cosine. And, okay, let me kind of write over here. What is the derivative of x, aka x to the 1st power? All right, the derivative of x to the 1st power. Again, this drops down, which doesn't really do it. It already multiplies the 1 that's already there. And then this gets subtracted by 1, so that is x to the 0, or aka it's not there. So the answer is 1. All right, so writing that a little bit more clean, d dx of x is equal to 1. It also implies that d dx of 3x is equal to 3. Because it multiplies down and reduces by 1. So here we go. The derivative of this x is 1. So the derivative should be 4 cosine of x minus 1. So what is that at 0? That would be 4 cosine of 0 minus 1. So the cosine is 1, so that's 4 times 1 minus 1. So this should be equal to 3. Using my calculator to confirm that, I go 4 sine of x minus x. Cool little wavy line going downhill. I want to know what is that slope, so I need to calculate the derivative at when x is equal to 0. And it says it's 2.99999, that's 3. That is aka the calculator version of a 3. Excellent. So 37, I have 3/4 e to the x, you can say e to the t, doesn't really matter. And then, so the derivative, e to the x is e to the x, so nothing changed. They want to know what is the slope of that when x is equal to 0. Anything to the 0th power is equal to 1, so that e to the 0 is 1, so that's 3/4 times 1, so this should be equal to 3/4. Again, confirming using my graphing utility, so this is going to be 3/4 e to the t, or aka x. And I want to know what is the slope, aka the derivative, when x, or in this case t, is equal to 0. 0.75. 3/4. Compare left hand and right hand derivatives shown in the function, not differentiable at point P. Find all the points F that is not differentiable. As I was implying last class, things that are not differentiable are corners, cusps, discontinuities, and vertical tangents. Vertical tangent. Okay, those are where things. So here we have the point of discontinuity. They say, look at the left-hand and right-hand derivatives. All right, so what we notice on this left-hand side is that this is a parabola. So if the left-hand side is f of x is equal to x squared, that implies that the derivative is equal to 2x. What is that derivative at 0? Well, it says that it's 0. Now compare that to the right-hand side, where its f of x is equal to x. That implies that the derivative is equal to 1. And then what is that derivative at 0? Well, it's still equal to 1. There is no x to replace with the 0. So what this is trying to hint you in at is non-differentiability is what is the derivative to the left and what is the derivative to the right. And they need to be equal to each other for it to truly be differentiable. Okay, so where is this thing not differentiable? At x is equal to 0, it's not differentiable. Okay, here the obvious matter is when x is equal to 1. So again, let's go with the left-hand derivative. The left of that point is the square root of x. So the left is the square root of x, or aka x to the 1/2. That implies that the derivative of that is 1/2 x to the negative 1/2. Again, it drops down and reduces by 1. So 1/2 minus 1 is negative 1/2. All right, so writing this just a little bit differently, that's what that is. So what is that derivative at 1, the point in question? Throwing in a 1 for all the x's, that is 1/2. The slope is 1/2. The right-hand derivative, okay, is f of x is equal to 2x minus 1. So its derivative is equal to 2. What is that derivative when x is equal to 1? It's still 2. There is no x's to replace. So again, the derivative from the left is saying that it's 1/2. The derivative of the right is saying that it's 2. Notice that these need to be equal for it to be differentiable. So where is this not differentiable? At x is equal to 1, it's not differentiable. All right, and the graphs, at what domain points does the function appear to be differentiable? Continuous, but not differentiable. Neither continuous nor differentiable. Okay, let's go with differentiable. That just means that it's smooth. At number 5. So smooth, differentiable, A. It should be differentiable over that entire span of -3 to 2. Continuous, but not differentiable. Because the whole thing is differentiable, there's no point that it is continuous, but not differentiable. So C, where is it neither continuous nor differentiable? None. Number 7, where is this differentiable? Where is this differentiable? So it is differentiable from -3 to 0. And 0 to 3. Okay, where is it continuous but not differentiable? The break in continuity is causing the mess up of differentiability. So there is no spot that this is continuous and not differentiable. See, where is this neither continuous nor differentiable? At x is equal to 0. It's not continuous and it's not differentiable. Again, continuous implies that you can go over the entire picture without picking up your pen or pencil. Differentiability just means that it's smooth. There's no sharp corners. Okay. Number 9, where is this differentiable? Everywhere except x is not equal to 0. So where is this differentiable? From -1 to 0. And 0 to 2. Notice how it does not include 0. Okay, it's a cusp. B, where is it continuous but not differentiable? At x is equal to 0. It's continuous. You never pick up your pen going over that point. It's there, it's not differentiable. Where is it neither continuous nor differentiable? It's continuous over the whole thing, so continuous, so it doesn't have a point of discontinuity. Find the numerical derivative of the given function at the indicated point. Use h of 0, 0, 1. Is this function differentiable at the indicated point? Oh, I see. I know what they're asking us to do. I know what they're asking us to do. Okay. Okay, I'm just going to kind of go over the way that we were just talking about. What's the derivative of this? That's 4 minus 2x. What's the derivative at that point? That's 4 minus 2, 0. So yes, it is differentiable at that point. Okay, I feel bad. I think I need to back up a little bit. Okay. Here's what I think they're asking us to do. Hopefully everybody remembers the continuity test. Continuity test implies that the limit left is the same as the limit right, making the limit, and then there's the point, and then the limit is equal to the point. So the continuity of this at x is equal to 0 would be, what is the limit as x goes to 0 from the negative? And now that it really doesn't really, so it's the same thing, 0. Okay, limit as x goes to 0 from the right. Okay, same difference, 0. That means the limit as x goes to 0 is equal to 0 because they're the same. Now let's test the actual point at 0. Oh, the actual point is 0. So what do I notice about this? Is that the limit is equal to the point. Sorry. Okay. The limit is equal to the point, thus continuous. Okay, so that is the continuity test. So again, what it is limit left, limit right. If they are both equal, that makes the limit. All right, that's a big step. So the limit exists, the point exists, and then the limit is equal to the point. That is the continuity test. Now, what this is talking about is it differentiable? So instead of the continuity test, we are asked to do the differentiability test. Differentiability, I think I spelled that right, test. And what the differentiability test is exactly the same process. Exactly, except you're dealing with the derivative of everything, and it must be first continuous. Okay, it has to be continuous, and then you can go ahead and do the differentiability test. Okay. I think that's what they're asking us to do here. Okay, so with that being said, I'm going to assume that this stuff is already continuous. I'm just going to assume that. All right, so what I notice about this derivative, okay, now let's test this derivative around the point 0. So the limit as x goes to 0 from the negative of f prime of x is 4. Again, I'm using my derivative. What is the limit as x goes to 0 from the positive side of the derivative? Well, that's still equal to 4. Thus, the limit as x goes to 0 of the derivative is equal to 4. Okay, so the limit left, limit right is equal to the limit. It's a big one. Okay, the next part is, what is the actual derivative at 0? Well, that's 4. What do I notice about this? I notice that the limit as x goes to 0 of f prime of x is equal to the f prime of 0. Thus, differentiable. At x is equal to 0. Okay, it's the exact same thing as the continuity test, but just with derivatives. So again, it's a five-step process. All right. Hopefully you guys know that limit left and limit right really don't matter much with this. So I'm just going to kind of start jumping through hoops here a little bit. This is the same equation. So the limit as x goes to 1 of f prime of x is equal to 2. F of 1 is equal to 2. The limit as x goes to 2, goes to 1, x goes to 1 of f prime of x is equal to f of 1. Sorry, I'm having a brain fart here. Thus, this differentiable at x is equal to 1. It's undefined. It's undefined. You can't divide by 0. again, division of 0. The do not exists aren't equal to anything, so they can't be equal even to themselves. So they're not equal to each other. In these problems, use the n-deriv to graph the derivative of the function. If possible, identify the derivative of the function looking at the graph. Okay. All right, so here's what they're saying. Use n-deriv. Okay, so let me back my calculator all the way out. There's a way to take a derivative of an equation at a specific point. And so where that is under this math button. If you go way down, there's this number 8 option, that's n-deriv. So that is taking a derivative. So how you set this up, like let's say I want to take the derivative of this negative cosine. So I go derivative of negative cosine of x. All right, here's where it gets a little crazy. You use this comma button and you say, what in this equation are you taking this with respect to? And it's almost always x. Okay, I'm going to be taking it with respect to x, put another comma, and then you have to specify what point you're taking the derivative at. So what is it when x is equal to 2? And then that is the value of the derivative at x is equal to 2. So kind of before when we did this using our calculator and the actual physical graph. So for instance, number 31, if I go math, n-deriv. Okay, what is the derivative of 8 divided by x squared, comma, with respect to x, at the x value of 2? It's negative 2. Or number 33, go math, 8, the derivative of 2x to the 4th minus 3 with respect to x when the x value is 1. And it's 8. All right, so what can I do to actually physically graph using that idea? And here's where it gets a little tricky. So I go to the graphing. And so if I were to graph cosine, okay, that's what the cosine looks like. But what does the derivative look like? All right, so here we go. So I'm going to go math 8. What is the derivative of negative cosine x with respect to x? And then here's where it gets crazy. Usually you have to specify a number, but when you're graphing, I just want to say at every single point. So this is going to individually identify each individual derivative and graphing. So comma x. And so this, it takes a little bit slower. This is the graph of a derivative using that n-deriv. So what does that graph look like? Okay, what does a swoopy line that go through that starts at the origin looks like? That looks like a sine. Or excuse me. Oh yeah, it looks like sine. And then we know that because, again, what is the derivative of cosine? Well, the derivative of cosine is negative sine. But what would the derivative of negative cosine be? Well, it would be negative sine. All right, so thus sine. The derivative is sine. And so by looking at the picture, that's what it'd be. All right, 28. Math 8, the n derivative of 0.25x to the fourth. Sorry, with respect to x at every x. This doesn't work in any other place but the graphing with that x thing. Disco. What does it roughly look like? It looks like an x to the third. It looks like an x to the third. And then we know how to take the derivative of this. If I were to truly take the derivative of this, multiply 0.25 by 4, and reduce the exponent by 1. Haha, it is x to the third. True or false? If f has a derivative at that, f is continuous at that. Again, what the differentiability test is, if it's differentiable. Okay, the first thing you have to have is continuity. You have to have continuity, all right? And then after that, okay, then after that, it's the continuity test, but just of derivatives. So the limit as x goes to c from the negative is equal to something, some number or something. And the limit as x goes from the right is equal to something. That implies that the limit is equal to that something. The point has to be equal to that something, and then obviously the limit is equal to the point. All right, so here, if we know that f has a derivative, aka it is differentiable, we know that it's differentiable. So what we know is all of these things are true. If it's differentiable, f is continuous. Yep, that is absolutely true. Yep, it's absolutely true. Because f is continuous, thus it has a derivative. False. Example. There. That's something that's continuous that doesn't have a derivative. Multiple choice? Oh. Formatting error. Okay. Which of the following is true about the graph of blah, blah, blah at da, da, da? X to the 4/5. Okay. I think that's technically a cusp. Okay, that's not a straight line. I know it kind of looks like it on my graph, but it's not a straight line. It's not a straight line. It's technically a cusp. And that's it. Okay, there you go, kids. There's a lot of stuff in there. A lot of stuff. Give it a try. Again, if you needed to remember one thing of today's lesson, the one thing of today's lesson is this. Is this multiplies down and then reduces by 1. That's the big. That's the derivative. That's the most important thing today.